Hello again. Hey, Pix. It's time for another Workbench episode. Finally, I had planned to do them more frequently than that, but man, the last one kicked my ass so bad with the super glue allergy, so I didn't really want to work on anything after that. Hi. Hi! Hi, Mouse. Thanks for joining in. So, yeah, this is going to be another Workbench stream, and it's time to work on scenery for the Model Train Club. I'm just going to go ahead and uh, let me know if the music is too loud, because I think it sounds louder in my headset than it does to the stream if I'm watching the meter correctly. I'm going to go ahead and switch to the camera. Hi. Um, so, uh, so I need to fix something. This is not the first time that I have worked on this particular thing. Not on stream, obviously, but in here is a signal bridge for our HO scale model railroad layout. Wow, that box smells like cigarettes. I have no idea how old this thing is. But this thing is kind of a problem. I actually used this not for a stream, but for a test recording the first time that I worked on it. Yeah, there's nothing in the box. Let me go ahead and switch to close up. Put that in focus. About there. Well, that is bright. Try that with the overhead light off. Yeah, kind of. So yeah. So this thing has been an ordeal that has been driving me and other people at the club crazy. Uh, so this is a signal bridge. He marked it 3 volts. It's not 3 volts, it's 2 volts. This goes on our HO scale layout. As originally built, this was designed for right side running. It goes over 2 tracks, and it has a signal here, and it has a signal here. As originally built, the signals were on the other side. One was here, and one was here. And this thing is ancient. I have no idea when it was made. That railing is a little bit bent, unsurprisingly. And it just... I'm going to go ahead and just cut off all of the wiring to make this less of a headache for me to show. So, death to you and death to you. And death to you. And death to you. Okay. All that shit gone. So originally, this thing had incandescent bulbs in it. And it was given to me saying, hey, convert this to LED for us. I was like, hey, I'd like to do more to help work on the club stuff. So I want to get involved with layout maintenance because not very many people do that. And to me, that's the more interesting part than the actual trains. How old is it if it had incandescent bulbs? Maybe 1990s, probably more like 1980s, 1880s, not quite. Does it say on the box? I don't think it does. It does say made in Japan. It also says that on the model itself. Yeah, there is nothing in here. Nor on the lid that says, I think... Yeah. IMP Takata. Made expressly for International Models Inc. New York, USA. Yeah, it doesn't have a date on it or anything, but like probably 1980s. Yeah, so yeah, it had incandescent bulbs and it was given to me. Convert it to LEDs, please. So I did. It is almost a perfect fit for standard 3mm LEDs, and that is what I put in there. Except that like the body of the LED, if you know how an LED normally has a flange at the bottom of it to prevent it from passing all the way through a hole, I had to take a bunch of LEDs and actually file off and carve off that flange so that they would fit into these. That is how perfectly 3mm those holes are. So very snug fit. It was given to me to do that when the signals were in their original spots. In fact, you can actually see the screw holes. It was originally screwed right there. The person who worked on it last told me that he fraught with the screws so much he decided to just solder it. But I worked on it. I replaced the LEDs and I reused the original wiring, which is pretty old, solid core, very small gauge, very brittle. Bloody hell. That lighting. Yeah. It's very old and brittle wiring, but I managed to get it working. Wow, that audio is like too much. Yeah, and it's like, so the wiring is held in by a bunch of metal tabs, folded metal tabs, right? There's one here and one right there. I don't know how well you can see that. Yeah, so folding those out to get the old wiring out, some of them broke off and I had to solder them back on. But like, I managed to reuse the original wiring because it's smaller gauge than any of the wiring that I have on hand. Oh, I forgot to grab the box of wiring. That's okay. I'll do that in a little bit. I'm gonna have to use, I think it's 32 gauge stranded core. Man, that is bent as shit too. That does not look very good. No offense, my friend, but that one looks kind of okay. Oh, there we go. So that, can I bend that? So anyway, yeah, I converted it to LED. The problem is, our train club does not do right side running. It does left side running. And the reasoning for that, it was originally built for right side running on the dual main line, drives on the US side, so to speak. It has one hill that is too steep for anything to get up. If it is going that direction. A lot of the model trains really struggle to get up that hill, and so sometime before I joined the club, they all collectively agreed to switch over to left side running, driving on the British side of the road. And that had... that fixed the problem. They tuned the track so it works really well for that. Good locomotives, like mine, can make it all the way around the layout without any problem going in that direction. However, one of the club members is like the current president of the club is like really adamant. Oh, I want to go back to right side running. And we tried it, and we tried it at one of the open houses, the last open house of the season, and terrible idea. A lot of trains did in fact struggle to get up that hill that people thought might not. They did. And also, like, the track is tuned really well, so everything runs really, like, reliably in the other direction. You tested in production. That is correct. Like, we tested once or twice on club days, and there were problems. And then the president was still like, fuck it, we'll do it live. We're gonna run on open house day anyway. That was a bloody terrible idea. That is probably the worst open house we've had in the time that I have been there. The worst open house that I have been to. We had so many problems. There are 3 turnouts, 3 switch points where trains were very frequently derailing because they're not tuned to run reliably in that direction. And also combined with that hill and also some wiring problems where one of the short circuit protection, one of the circuit breaker boards for one of the track blocks basically went bad and had to be replaced. That was a nightmare. That day sucked. But anyway, so we have all collectively agreed, fuck it, we're sticking with left side running. So this is about the time that this thing came onto the scene, when we're like, okay, we'll put it in this spot or maybe this spot, and it'll be fine because we're going back to right side running, so it's fine that the signals are on the right hand side. I converted it to LED. I gave it back to the layout manager, and the layout manager tried to figure out for days where to put it after we then decided, no, we're going back to left side running. And he finally gave up, took it home, and pulled off the lamps, pulled off the signals, and moved them to the other side. So now it is set up for left side running. Cool, works on the layout. In the process, he fucked up a bunch of the wiring. Like the old brittle wiring, rerouting it after I had worked on it already. Some of these are intermittent connections. And so this leads me to a rant that I need to make. 3 consecutive generations of Americans, and probably the rest of the world, for some reason that I have not divined, I don't 100% understand why, learned soldering, electrical soldering, in the worst way possible and have taken that as gospel. I've watched the layout manager who, okay, for context, this guy was a pharmacist. His electrical engineering experience is entirely from working on the layout, and he's been working on the layout since I was a little baby. He's been involved in model trains since I was a little baby, but he is also self-taught at electrical engineering by working on that, much like I am self-taught at electrical engineering from working on flight simulator hardware. And I have watched him, like, I don't want to go in there and tell the old guys, the guys in their 60s and 70s and 80s, hey, you're doing this wrong. You know, when I'm almost 40, but I'm still a whippersnapper in their eyes. But he's generally pretty competent, but I have watched him solder very closely. And I watched a couple of the other club members solder not very closely. And basically I have 2 rules now when it comes to electrical wiring at the club. Number 1, if I need to solder something there, I'm taking my own kit. I'm taking my own iron. So, because they don't clean off the tip of the iron after they have been using it, and they leave it plugged in way too long without using it, and so it's like, at last glance, the tip on that iron looked fine, but I don't know how recently they replaced it. But yeah, if I'm going to solder something, I'm taking my own kit so I don't have to work with their shit abused tools. And number 2, if I want something to work reliably, I'm soldering it myself. Because I have watched the layout manager solder before. I was actually going to say, somebody asked me, the manager and I were working on the layout. And one of, because I don't want to go in there, like, I'm in charge now. One of the other club members watching us work was like, so are you the electrical engineering manager now? And I'm like, no, I'm the apprentice. And the layout manager cracked up laughing and said, that makes 2 of us. So, but I have watched him solder, and the way that he solders is the correct way to solder, according to textbooks from the 60s and 70s and 80s and 90s, and the way that my dad tried to teach me to solder when I was a little kid. And it is a terrible fucking way to solder, and I don't understand why people learned doing it this way. I think it might have been because soldering iron tips back in the day were bare copper. They weren't iron plated, and therefore there were different concerns when, like, taking care of a tip and not letting it corrode. But I wanna show a graphic so I can bitch about this. Let me go in here in OBS and turn this on. So I just pulled this off of frickin', what did I pull it off of? Instructables. This is the way that they teach you how to do electrical soldering. You heat up the components using the tip of the soldering iron. Before applying any solder, you heat up both the pad and the lead, or if you're wiring two wires together, you heat up both of the wires together with touching the soldering iron to them. You wait until they are hot enough, and then you touch solder, not to the iron tip, but to the thing that you are trying to solder. You touch it, once the wire or lead is hot enough, you touch it to the wire or lead, and the solder will melt and flow onto that. And the problem with this is that this is like trying to fry something without using any oil. If you think about, like, surface contact of rounded things against flat things, or rounded things against other rounded things, like, think about the wheels of a train on the track. The surface contact is about the size of a dime. The surface contact between the soldering iron, yeah, slippage is an issue with those. But which is why they have so many damn driving wheels, to try to increase traction. But the iron, if you think about how much surface contact there is between the iron and the wire or whatever, it's such a small amount, like it's a pinhead size contact area, unless you're using like a flat tipped iron against a pad, and no heat. Like, the amount of heat that can conduct through that, one-dimensional contact point is like practically nothing. So it takes way longer to heat up the workpiece if you are using a dry iron tip, which means that one of the problems with that is that you spend more time applying heat to the component. That is more time for heat to propagate and conduct through to other parts of the component. And so you take longer heating it up. There's more time for heat to get into the rest of the thing and damage it. And so you're way more likely to burn out LEDs and transistors and ICs and stuff if you're soldering them like that. So the trick is you have to put solder on the tip of the iron before you start soldering. It acts as a thermal interface. The blob of solder that you put on the tip of the iron first will wrap and conform to the iron tip and have a large amount of surface contact for heat to conduct into the molten solder. And then when you touch it to the workpiece, that molten solder, it won't adhere to the thing that you were trying to solder yet, even once it gets hot, because there's no flux in it yet. But the flux burns out when you apply it to the solder tip. Yeah, the otter tip. Sorry. Again, I say this every time, but didn't sleep super well last night. Yeah. When you then apply the blob of solder that is on the solder tip to the workpiece, it conforms to the shape of the workpiece with a large amount of surface contact area. It doesn't adhere yet, but a large amount of heat is able to quickly conduct out of the blob of solder into the thing you are trying to solder, heating it up to soldering temperature way, 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 way faster. And then you can apply your, soldering wire to the joint, and the flux, the basically oversimplifying for anyone who doesn't know, basically high temperature soap that cleans impurities. It cleans the oxides off of the metal contact areas so that they can adhere to each other, and it floats to the outside of the solder or whatever. That is in the solder wire itself. This stuff, let me switch to the close-up. This is hollow. You absolutely cannot see it on this camera, but the solder wire is hollow, and it contains pine rosin or something similar to it that cleans the joint. So it's like, yeah, the blob of solder that is on the soldering iron tip isn't going, like, as soon as you do that, the flux that is in it burns out. And so when you apply this, that's like that's why they tell you in the old method, oh, don't apply the solder directly to the soldering iron tip, because the flux will just burn out it'll stick to the iron tip, and then you try to apply it to the workpiece, and it will not stick to the workpiece because it can't clean the workpiece. But that's not the point. You put solder on the tip, and then it heats the workpiece way faster. So, yeah, it drives me fucking crazy watching the old dudes solder, and I don't understand. Like I said, I think it might be because they were using like bare copper soldering tips and they didn't want to get solder on it as much as possible to prevent corrosion. But like modern soldering iron tips are iron plated; they're ironclad, so that's not really a problem as long as that cladding doesn't crack. Which the cladding can crack if you put too much mechanical force on the iron tip, which you're doing if you're trying to press it really hard into the workpiece because it's taking forever to heat up the fucking wire because you're using a dry iron tip. Anyway, so that's my fucking rant. So that is why this stuff has just god awful. Let me turn this shit off. Uh, reliability in the connections. It causes so many problems, and so it's like to the manager. I haven't brought this up yet. I haven't said anything. I don't want to be mean, but it's like, my dude, please just let me solder everything from now on because this is terrible. This is terrible technique. Anyway, so he repositioned these. He broke these off, or unscrewed them rather, tried drilling holes for them, I think, and then couldn't get the screws back into those holes and decided to just solder them on. And that's fine. It looks fine, I think. And rerouted the old brittle wiring that I had reused, routed it differently, and that probably caused problems on the backs of some of the LEDs. And then he soldered, you know, that big bundle of wire that I just cut off. He soldered really long pigtails to it to run down to wire into, the electrical system underneath the layout. And I'm sure that those connections are terrible. In fact, you know what? I want to pull those apart and look at them. I'm going to set this aside for a minute. And I'm going to take one of these. And we're going to cut this open. This is the manager did this. The green and white here, that's the old wiring that I reused, and I just left them exposed and tinned. So this wiring, the red and black here, that was added by the manager. And I'm going to get a penknife and cut off. Oh, where is it? Pardon me while I dig through my toolbox. There it is. I need to replace the blade on this, but counterpoint, there are a lot of things that I do that are kind of so abusive to the knife that, like, it's better to just use one that's already worn out. But I'm gonna very carefully slice this apart. Like, kind of trying to peel it like banana, kind of. Very carefully without wrecking the wiring underneath. At very good chance of stabbing myself in the fingers, which is not great, but whatever. Come on. Yeah, doing fucking shaming and exposing my model train club manager on stream. Come on. Getting there. How's the music level compared to my mic level? I have learned not to trust the watcher count on the Restream chat app, so I have no idea how many people are watching aside from you, Pix. I don't know if Mouse is still here. Come on. All right. Oh yeah, that'll work, I think. Do I have anyone who... Okay, hey. Stardew audio is louder than the music. Oh, yeah, okay, that's fair. My brain took a second to parse that. I was like, what are you talking about? It's Starbound, not Stardew Valley. Oh, wait, your own music. Derp. What's the best lighting option here? Bring that into focus. Yeah, that's not great. I think that's actually better if I just shut off all of the lights and use the ambient light from the window. That looks like dog shit. I do not approve. That's also like literally right about to break off. Like the old wiring is so brittle at the edge of the connection that that is just about to split, which that isn't the manager's fault, but that connection to the copper below is bad. Anyway, if you can't hear the Starbound music over the Stardew music, but you can hear me, then I'm going to go with that, meaning that the audio level is good. Yeah, I don't like that. So, yep, there it goes. So we're going to get rid of that. We were having a ton of problems at the club trying to get this thing to work. He did that. He converted the lighting to the other side, and then he has spent the last 4 days trying to get it installed and working and absolutely fighting with the wiring. And finally, yesterday, while I was working on other stuff, he called me over to have a look at it to try to diagnose the problem. And this is something that's really important to me. When I was in automotive trade school, I had a really great professor named Kevin, who worked in automotive maintenance for decades and decades, and he was really good, really knowledgeable. And one of the things that he drove home to us was that replacing parts is easy generally. Sometimes they're heavy, but generally once you know what the problem is, fixing it is usually not that hard. 90% of your job as a maintenance technician is figuring out what the actual problem is. And so he spent the line that comes from the computer that controls the layout and is supposed to drive these LEDs. He had to connect it up. Sometimes the LEDs weren't working. Sometimes they were. Sometimes, it was intermittent, and sometimes they were bright, and sometimes they were really, really, really dim. And so I went over there with all of my meters and stuff and tried to figure this out. And one of the things that I discovered was that the polarity was wrong. It's not signal interference. I'm pretty sure it's not signal interference. There is a lot of possibly interference generating shit under that layout. No, the problem is if you put a meter across the signal line where this thing is supposed to connect up to it under the layout, if you put a meter across that, if you put a digital multimeter across it, it shows 4.8 volts, which is okay. That's close enough. It's supposed to be a 5-volt system. Which I'm gonna take this. Do I want to take the 3-volt stick? I'll just leave that on. The manager will be like, "Why'd you take that off?" Whatever, doesn't matter. So I put the digital meter across that, and I was like, okay, what's going on here? Um, it says it's 4.8 volts when I measure it, but when I connect the LED to it, it's very, 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 very dim. Even with no series resistor, because the LED is only supposed to be 2.2 volts, uh, 2 to 2.2, and you're supposed to run it with a resistor in series so it doesn't burn out when you're running it on 5-volt power. And even with no resistor on it, it was super dim. So, but while measuring it, we were measuring the voltage with the LED disconnected. And I had measured it with my he measured it with his digital meter. I measured it with my digital meter, which they agreed with each other, 4.8 volts. Then I got out my analog meter. I really like having an analog meter. I really like using these. I think these are wonderful. I think these are underappreciated in the modern computer era. I checked it with this, and it said, oh, it's 4.2 volts. So, well, that's weird. And because the analog meter does have lower resistance, it draws more current when it is measuring voltage, which means that if the voltage supply, yeah, I know, right? I love them. I use them a lot in automotive school. It was great. One of the things that we were taught very specifically and very weirdly was how to pull computer error codes from a 1993 Ford Topaz using an analog meter or a headlight bulb, because it was designed to put out the computer codes using that rather than any kind of computer scan tool. And what's really funny is that, like, after I was no longer doing automotive stuff, that is one skill that I did actually use, because one of my friends from high school had a 1993 Ford Topaz and was having problems with it, and I was like, oh, I can check what's wrong with it in the weirdest, goofiest looking way possible. Anyway, yeah. So I'm like, okay, the voltage should not drop that much. Right? Love that. The voltage should not drop that much when I check it with the analog meter. And so it occurred to me, we haven't measured the voltage drop across it when the LED is connected and trying to light up. Connect it, we were only trying to do one side. Red LED was illuminating, stopped illuminating entirely eventually, and I'm pretty sure that was an intermittent connection because I, at that point, couldn't get any resistance reading through it in either direction, so it wasn't a polarity thing when checking the LED for continuity with my meter. Checking the... so the green LED was still working, so I connect the green LED up to it. I try to measure the current through it using the analog meter, and it's showing almost zero current running through the LED, coming off of the red signal output from the computer. So I checked the voltage across it with the LED attached, and whoops, it dropped to 2.3 volts. Even, even with the resistor attached to the LED. That, as soon as you put any load on it and try to draw current, it was dropping way low. So I checked it again on the other side on the green output signal from the computer, and it dropped to 1.3 volts, which is not even high enough to illuminate the LED. LEDs have a minimum ignition voltage, which is why you control brightness with pulse width modulation, PWM, rather than with actually analog voltage control. Yeah, so the frickin' that was pulling the voltage down so much that it couldn't even light the LED, even though there was current flowing through it. So I'm like, okay, either this is hooked up to a logical output that isn't meant to be an LED line driver, and it's meant to go into like high impedance inputs on like a logic circuit, or the other end of this cable on the other side of the building is fucked up, like bad connections. Gee, I wonder why. So I'm going to go to the club tomorrow morning. I'm going to have this thing finished and converted, replacing the wiring so that it's no longer broken and intermittent, so that's not a problem. And then I'm going to take it to the club and I'll give it to the manager and he can put it back in. But unless he has gotten to it today before I have, I'm going to chase the other end of that cable and find the bad connection in it somewhere. Or it could be that the cable is just too long and there's too much voltage drop, but that seems excessive. Like, that seems really excessive just for cable resistance. So, yeah, I have no idea what's going on. This is why I stepped up as like electrical engineering manager assistant. Uh because we have so many problems that are from like, this layout has been built piecemeal over 20 years by dozens of people with no coherent plan and varying skill level at electrical engineering. The underside of it is a mess. If you look at my Twitter account, there is a photo underneath where I put the caption of something that I had said to the manager, which made him crack up laughing. The downside of having figured out how to turn on the lights under here is that now I can see the full extent of the horrors which lay before me, because I have volunteered to reliability check and label and redress all of that wiring. So, and by God, I am going to do that. But yeah, now I have to put the current thing, 12-volt lighting supply that I've been working on, put a pin in that and chase the other end of this fucking cable that's supposed to drive this signal. But for right now, what we're going to do today is pull these LEDs out and just completely, entirely replace the wiring. I'm also going to, it bothers me so much that this step isn't square to the structure. I'm not gonna resolder that. I'm not gonna touch that. I am gonna bend it into line. You can see the close-up camera has manual focus adjustment, so I'm like constantly playing with that. That's why it's shaking so much. Yep, just a little tweak. There. That looks better. And there's a bunch of schmutz on it. Whatever. It's really awkward constantly looking at over at OBS to see if you guys can see the same thing I'm seeing. Oops, that bent down a little bit too much. Okay, there we go. That's fine. Whatever. Now, I need a tool to punch the LEDs out. And toolbox from hell. I really need to get a better solution for storing all of my small tools, but somewhere in here, there's also parts that I like pulled parts out of the layout that are not in use. Ah, here we go. Pull this out of this pin vise. Yes. Like, that little box is held closed with a magnetic closure. It doesn't even like latch, so if I ever drop it, it's like fucked. But I'm going to go ahead and just push these out. Okay, those LEDs are out. And then get some appropriate pliers for, let's see, I'll have these, they're smaller than the other needle nose. And let's see. Screwdriver to use as a pry tool. I want to use those tweezers. No, I don't. I want to use these tweezers for this application. Later on, I am going to be soldering. Hey, Crack! How you doing? Thank you for tuning in. I know you're on lunch break. Yeah, go ahead and punch these out. You missed a 40-minute long rant about how none of the old men at my model train club know how to fucking solder correctly. I'm sorry that you missed that. Okay, so that's out, and then I have to bend up all these little, let's use the screwdriver for that, little tabs. That is a hard one to get to. Come on. Okay. Inevitably, some of these are going to break off while I'm working on it, and I will have to resolder them. Is this better with this light on? Yeah, kind of for this. See down inside there. Yeah. Okay. Then this is one of the ones that I soldered on, or just replaced it with a chunk of wire. Get this one out. And that one wasn't even done. Good job, Mr. Manager. It out. Yeah, trying to keep this in frame while I'm also working on it is slightly tedious, but whatever. Okay, there we go. That out of there, and I will reuse the LEDs. I'm pretty sure I'll reuse the LEDs. I think they're still good. Wow, that has to be repainted. In fact, I think the whole thing has to be painted. I don't know why he hasn't painted it before trying to install it. That seems like it's going to be even more trouble pulling it back out afterwards to do the painting, but whatever, that's not my problem. I do electrical, not paint. Yes. I Okay. Hello, Auckland Public Library System. Thank you for your support. The focus on that. Yeah, I guess that's good enough. Oh, that one is right on the verge of breaking off. I'm going to have to resolder that. I'm just going to go ahead and break it off. That will have to be... Come on. Okay, these are not very good tweezers. There. That one's off. That's going to be trash. In fact, almost certainly soldered on with lead. So I care about the environment and I don't want lead going into the landfill. So I have a giant fucking jar that I just put all of my leaded waste in. Because here at Sapphire Blossom Laboratories, we actually give a shit. I do use lead solder, 6040. What happens when the jar is full? I haven't filled it up yet, so I don't know. Like, this is probably 4 years worth of soldering waste. I'm sure that there is a place that I can take it to dispose of it, hazardous waste. Yeah, so but I do use leaded solder because as a hobbyist, it's way fucking easier to work on. Ask again in 10 years. Exactly. Okay. So I'm going to set that aside for right now so that I can work on these. I had forgotten that I painted the backs of these after I put on the heat shrink. I painted the back so that there wouldn't be any light shining back through the wrong side of the signal. Hopefully that doesn't cause anything weird when I'm soldering on them. But anyway, so I need to strip these off entirely. Yeah, it looks about good. Shut off. Yeah, okay. Yeah, I'm still, this is, again, Workbench stream number 2, so I'm still working on what the best lighting situation is, and it's constantly changing depending on what I'm doing. I think I'm going to go with that for right now. Where is it? About there. Anyway, yeah. These are basically a perfect fit, the LEDs. However, the heat shrink around the leads is actually too big. And so it kind of peels back slightly as it's being pushed into the signal, the thing that it goes into. And so after I'm done, one of the things that I did and will continue to do is make sure that there is no conductivity between any of the LED wires and the metal frame of the signal bridge. That is important. Come on. Yeah. Using the penknife on this is extremely fiddly, so like apologies, there's no guarantee that there won't be a small amount of blood on this stream. That. And then later on, once I am actually soldering, we are going to have to do a little bit of an experiment. I am going to need uh, assistance from a volunteer, by which I mean I need chat to help me with figuring out the best audio solution, because of this thing back here is a fume extractor fan so that I don't need to breathe solder flux fumes. However, it's kind of loud, and so I have to have noise suppression on for OBS. However, yes, thank you. For context, there is an alarm system at the train club that I built and installed to prove my electrical engineering chops to everyone at the club and also to help the club, where if people leave the exit turnouts from the main line open for too long, it yells at them. And the person currently commenting in chat is the person who voices that alarm system. Please close upper exit staging turnout, or whatever it is. Yeah. So I again thank you for your assistance. That thing has been so invaluably helpful at the club. Many, many, many people have commented on how useful that system is, and I'm very smug about it. I don't think the fan will help with super gluing. One of the club manager, actually, when I mentioned it, he gave me some modeling cement, which is not CA glue, so I'm going to try that possibly later tonight. Right. There's a second thing that I want to work on. That I might not get around to tonight. That might be for next Workbench stream, depending on how long this takes and how late this goes. But he gave me some non-CA. Oh, wow, that just fucking broke. Fantastic. All right. Sure, why not? Okay, so I'm gonna have to clean that up. Yeah, I don't think that the fume extractor fan, because it's just like a foam smoke filter. I don't think it'll help with organic vapor problems. But it's kind of loud. And having the noise suppression turned on full blast on OBS, the high quality noise suppression, it does completely filter out the sound of the fume extractor fan. However, it also kind of filters out me as a result anytime I try talking. Like I tested this in recordings. Anytime that I try speaking while that is going on, I sound extremely garbled because of it. So, like, hitting the sweet spot of noise cancellation versus fan noise being annoying in the stream. I don't know. We're gonna have to figure that out. I'm going to need assistance for figuring that out later on when it is time to actually solder stuff. But it is now it's on a foam riser. Like this is foam sound baffle that I just cut a chunk out of to set it on top of so that vibration doesn't transmit anxiety with the knife, because that's legit. Focus. Yeah, it's sitting on top of a big block of foam, which is reduces noise transmitted through the layout, but also the microphone is on an entirely different table. I'm sorry, there isn't really a good way to do this. But I appreciate your concern for my health. Anyway. Come on. In before more wiring just outright tears off. Which I think it's probably going to. Okay. That one is off. No. Like, all I can say is that I understand the risks. You have first aid. Okay. That is 2 down. And yeah, trying to find proper focus in this camera is a constant struggle. But also, that's why I'm being kind of quiet right now, is because I'm trying to focus on this. Also, I need to fucking put my phone on Do Not Disturb. So, I have issues with my phone, which is that I'm now receiving notifications, like incessant notifications, like every 5 fucking minutes. It's time to upgrade to Android 14, and I've not done it yet. And I don't want to do it until I know what Android 14 has changed. Because I see the trends that have been going on, the shit on Google and on Facebook. I don't want this to add a bunch of AI crap to my phone. So, if anyone knows what the features of Android 14 are, I would love to know. If not, I will just look them up myself later. But like, I think if that has like integrated AI shit in it that I can't opt out of, I'm not fucking upgrading it. Because I hate that. But I'm not going to rant about that because that's not what this channel is about. This channel is about me ranting about old dudes not knowing how to do electrical solder correctly, apparently. Yeah, no worries. The enshittification scale. Well, we'll find out together. Or I'll find out on my own, one of the two. Okay. Here we go. That is Liberated LED number 3. And this will be number 4. Yes. Come on, focus distance. I think it's about there. It's not a great webcam. Like it's just a cheap fucking God, what's the company that makes all the cheap shitty webcams and mice and stuff? I can't believe I'm drawing a blank on that. iOmega? I think it's iOmega. No, Logitech. I keep thinking iOmega zip drive for some reason. Dating myself with that. Yeah, it's a cheap. It's a 720p, like bottom tier Logitech webcam that I have taken apart and modified to have a manual focus adjustment dial. Because the thing is, focus on that is set by how close the lens is to the CCD, and the lens is just threaded in to the mount, and you can screw it in and out to change the focus. And so they do that manually at manufacture. They set the focus. Someone has to set the focus manually by screwing it in and out, and then they just hot glue it in place. So I just opened it up and pried off the hot glue, and then added like a section of tube that comes out the front of the camera housing and put like a medicine cap on it as a dial so that I can manually adjust the focus, and it is attached to my swing arm magnifier, because then that doubles as the ring light for the camera. Okay. Cool. Last LED liberated. Huzzah! Get rid of that shit. All right. So dial in there. See ya. Thanks for tuning in. Get rid of this, and I'm gonna switch to overhead view for a minute. I have to step away from the workbench for a second to go grab my 32 gauge wire. I think it's 32 gauge. It's not that. No, it's not. It's also, I think that's 28 gauge. Oh, here it is. Yeah, this is it. Huzzah! Wires. Would you like to see my wires? Okay, so I'm going to... What am I going to do? I'm not going to actually wire them yet. I am going to clean them up, and then I'm going to test them in a breadboard with a power supply to make sure that all of them are still functional. So, actually... That's about good. Yeah, okay. So I'm going to clean this up. So it's going to be fan time. The fan is now running. So comparing music, which I have just turned up very slightly to try to mask some of the fan noise, compared to me, both in terms of volume and quality. How is this? As I go ahead and plug in my iron and warm that up. No difference with the fan. All right. Fuck it, I'll take that. Wait, what am I doing? This. Tweezers. Different tweezers. Right there, you can see the blue tape that I put on there to indicate where the edge of the other camera starts. There's about that much of the desk. Yeah. I think if I... Oh, give me a second. I put this piece of foam underneath it for contrast. Now we can both see the thing. So that's probably about as good as it's gonna get. Anyway, as cobbled together as it is, I'm very proud of this recording setup. I'm really happy with it. Oh, let me see. I also need a solderless breadboard and some wire. Some like solid core wire. I'll deal with it after I do this. No, I won't, because it's still warming up. I have time right now. Solderless breadboard. Where is that damn thing? My office is such a mess. I really need to work on this. That's the power supply. Oh boy. Shit, I actually don't know where my solderless breadboard is. And that is extra annoying. Oh, did I put it? Oh, there it is. Found it. And let's grab this box of hookup wire. There we go. Okay. I have the things that I need now. We got it. Yeah, I'm just kind of running on faith that this all sounds better to you than it does to me. Because the fan in my headset monitor is so loud. All right, so we're just gonna pull these off. Clean that a bit. There we go. Always trying to get the damn focus just right. Yeah, it's not going to get better than that. All right. It's one LED. That is two LEDs. Yep. There's kind of. Okay, there we go. There's three LEDs. Terminal clean better. I don't know, to fuck up this bridge, I'll just set it back here. There's four LEDs. Try to get this lead cleaner. You know what I'll actually do? This is incredibly goofy, but I'm going to use the desoldering piston to clean that. Go. Whoops. What did I knock over? That rolled off. Why did that roll off? Whatever. Fusion abounds. Okay. Four LEDs. Fan off. Soldering iron clean. Soldering iron off. I always hang the cord for the soldering iron around the iron after I'm done with it to confirm to myself that it is unplugged. So, okay, breadboard. Do I have a, what is that? I think that's a 1K resistor that's on there. I think red is 3 zeros or 2 zeros. Yeah, red is 2 zeros. That's okay. 1 0 and 2 more zeros. That should be 1K. And that is already wired up the way that I need it to be wired up, actually. So, myself a bit of hookup wire. Which I'm sure there's already pigtails around here somewhere like that, but whatever. Put that down there so we don't lose it. Power supply. Which one is 5 volts? V1 is 5 volts. This is a dual 5 volt and 12 volt supply. So V1 is 5 volts. Wire cutters. The wire strippings do not really contain lead, but I throw them in the jar anyway because, you know, it doesn't hurt anything. And where the hell did that screwdriver go? There it is. goes to common. Doesn't actually matter which common because they're tied together, but we'll go to that one. Is the fucking cover on this thing loose? No, it's not. It's fine. Red to be 1. 1K is a really strong resistor to be using for 5 volts. But I think it'll still illuminate. Okay, that is connected. So there's a mnemonic trick that I use for remembering which way LEDs go. So I can get this thing. There we go. So I don't know how well you can see here. Try turning on this light. There is a triangular piece of metal inside that is connected to the left lead in this picture. And it has kind of a bowl shape on top of it. This would be easier to show with a bigger LED. I can just grab a bigger LED. I have bigger LEDs. Somewhere I have bigger LEDs. I'll just grab this box. Ooh, clear ones. Which are either white or infrared. I think they're infrared. Yes, this is infrared. Although that has a really weird looking anvil in it. So I won't use that one. Ah, warm white. These are good. I will use this. Yeah. So here's a fun mnemonic. If you can see, there are 2 pieces of metal inside. One is much larger than the other one. And it has kind of a bowl shape, which if you look straight into the end of the LED, you can see that bowl-shaped thing very greatly magnified. But that is a little cauldron formed on top of the larger of the 2 pieces of metal. That piece is called the anvil. So, dropped it. It's really awkward to do this, but yeah, the left lead is connected to what is called the anvil. I don't remember what the other one is called, but it doesn't matter. The right lead is connected to the other one, and the little bowl on top of the anvil has the actual LED in it, the little tiny semiconductor die. And the other one, not the anvil, has an itty bitty teeny tiny wire that bridges the gap and connects to the top of the semiconductor. And that is the bond wire. I don't think you can even see the bond wire here. It is so small. And then the whole thing is just encased in clear epoxy. However, yeah, the piece that the semiconductor die is mounted on is called the anvil. And you may or may not recall in actual circuitry that the general convention, the red lead is positive and the black lead is negative, and the negative voltage in DC circuits is also called the ground. And the easy mnemonic for which way around the LED goes, because they are polarized and it does matter, is simply that anvils sit on the ground. So it goes in like that, actually. The resistor goes to ground. If I plug this in, power supply. There we go. Wow, yeah, that's a bit bright, actually. unpower that. So I'm going to use that to test these. Where is the anvil on that? Okay, it goes this way. Come on. Okay, I can actually just leave this plugged in. Yep, that is illuminating. With a 1K resistor that is so fucking dim. I'm actually going to get a proper 220 for this. Because there is no way. I want to be confident that these are working correctly. I believe this is 220. Check it with the meter. Slowly, I have been learning to actually read the color codes on 3-band resistors. I still can't read 4-band resistors. They're much more difficult. Often because they're blue, which makes the colors of the bands much harder to tell. Okay, this is actually showing 204 ohms. Because they're not very accurate to what they're labeled, but that's okay. Good enough. So connect that to ground. Okay, now put that back in. Yeah, that's brighter. That's relatively decent. Okay, so this one is known good. And Bill's on this side. That one is known good. That one is a bit brighter than the other one. They're actually different brands because I used one of my own LEDs for one side and then I was out of green LEDs and I had to get one from the club. That way. Did I have it backwards? Oh, interesting. This one is dead. This one is dead. I think the club manager might have overdriven it while testing it. I will check it with the continuity meter. Yep, that one is fucking dead. So we're gonna try it just to confirm. The other one, sorry, I'm not doing this on camera. It's just way easier in my lap. Yep. Okay, this one should be good. Okay, so I have a dead LED. That one, oh yeah, that one works real well. So 2 green working, 1 green red. This one is trash. That takes care of that. That's why that one wasn't working last night. So I need to grab another 3mm red LED. Think. Okay, I picked one up and then accidentally launched it across the room. Brilliant. Try it with this one. Oh yeah, that works. Okay. There we go. So that means that I'm going to have to cut the flange off of that one. Go ahead and set that aside for now. Set this aside for now. And shit. Okay. So I am briefly going to have to don a dust mask in order to do this. Pardon me for a moment. I want to add a toggle to my model so that I can put a dust mask on it. But I don't like, I could probably abuse the Vroid hair tool into making a mask. But, okay. So unpleasant. I will put down some aluminum foil while I do this to collect all of the dust. Okay. Yeah. In. And the dust mask is bumping into the camera because the camera is so close in front of my face. Brilliant. I do want to make sure, okay, that looks fine. That looks fine. Make sure that the leads are not sticking out the sides of the LED because I did actually find one like that. I was really hoping I wouldn't have to do this. But here we are. The things we do for love. By which I mean hobbies. Also, the mask is causing my safety glasses to fog up. Oops. That doesn't really matter. That side of the LED isn't going to be visible. So I don't care that much. See how that is for fitting into this. Nope, still, oh, yep, okay. We're good, actually. That fits. That is done. Huzzah. Okay. Now I will trim the leads short. I set the wire cutters. There they are. Trim them about that long. Go. Okay. So there we go. Now, let me get rid of the dust mask because it's uncomfortable. Always wear safety glasses, kids. Man, the leads on that one are so short. Okay. So I'm going to do something a little bit different here. I don't want there to be red wiring visible inside of this thing. So I'm going to use entirely black wiring above ground, and then down here I will pigtail to red and black to correctly label the polarity. So need, call it about, I can actually test this just by running it in here. It goes through this hole. To there. It's plenty of excess. So yeah, I'm going to call that good. Put it there. So I need 8 of those. And then I can actually reuse the wiring that the manager used for the below the table part. Two. Three. Four. Come on. 5. 6. 7. And 8. Okay. There's that. Then there's this fucking mess. I think we'll actually... You know what I'm going to do? I'm going to use red wiring for the positive on the red LEDs and green wiring for positive on the green LEDs. That will make life ever so slightly easier. Get rid of the freaking vinyl tape. Okay. Cut off the manager's terrible fucking soldering. And the other end of the manager's terrible fucking soldering. There. That might be better for seeing the tinning job on the end of that wire. We're going to hack that off. Throw it in the naughty bin. And... Oh, come on, brain. Where did I put down the strippers? There they are. So I need about, yeah, that's about good. About the same at the other end. Wow, okay. Let's try that again. Yeah. There we go. Okay, that is one red wire. And then, okay, I guess he used orange wire for the other. That's fine. Oh, no, he didn't. There's the other red. Get rid of the fucking vinyl tape. Cut both ends of it. Strip. There's two red wires. Now I need 4 black. Or I guess he used brown for the fucking negative there. Oh, I see what he was going for. Orange and brown on one side and black and red on the other. Yeah, I understand. All right. Well, 2 can play at that game. So we're gonna do red, black. Nah, fuck it. I'll just color code the heat shrink on it. We're not doing that. Although for the sake of not using up a ton of my own wiring, I should reuse the brown. That. Cut off the ends. Oops. One black. Here's the other black. Strip it. Other end. Okay. Wow, good job. There's fucking solder on the insulation there. That. That. Okay. That. So I got 2 browns, 2 blacks, 2 reds. And I will go get some green wire. Stranded 28 gauge or whatever the fuck it is. Oh, let's use this. The big shit. No, it's a 22 gauge. And it doesn't match the other because it is silicone insulated, but that's fine. In fact, that's preferable. Silicone insulated wire is fantastic because the insulation doesn't fucking melt when you're soldering. Right, so there's a green. And there's a green. And I'm going to go ahead and start the soldering iron because that is going to be used in a few minutes. Noise mode once again. Okay. Stripping wiring tends to be an extremely tedious part of all electrical work when doing discrete stuff like this. The amount of time it took me to wire my Nixie tube clock was insane. Because once again, all you can eat spaghetti night here. Those are stripped. Now I need to get the little itty bitty ones. Which these wire strippers don't actually fit. Okay. So I just have to use like the cutting edge to do. I am definitely not getting to the signals, the grade crossing. Yes. Oh my God. Doing RJ45 connectors by hand. Brown, white, brown, blue, white, orange, orange, white, blue, green, white, green, or whatever the fucking pattern is. I had to wire the whole security camera system at my family estate. Because my dad was like, here's the tools and the connectors and the cable. Make me a bunch of cables. Oh my God. Even in the junction box, like there's no punch down connectors in that system. So that was infuriating. 3 down. Green, white, green, orange, white, blue, blue, white, orange, brown, white, brown. That's the pattern. That is the A connector pattern. Which for a while was my madness mantra. Okay. It's 5. The iron is ready. I am almost ready for it. Yeah, for me it's been about 5 probably. Two more. And I'm still not certain that I didn't make any mistakes in that system, but all of the cameras seem to work, so I guess it's fine. It's just so monotonous and mind-numbing after a while. Okay. There's all of that. Now what? I'm going to assemble the wires before I put them on the LEDs. So I will need the, whoops, third hand and the fourth hand. Okay. Just going to go ahead and tin both ends of every wire for starters. I'm running out of solder. If anyone wants to buy me a fucking spool of leaded, tin lead solder, that would be fantastic. But yeah, they sit there with the fucking dry iron on the lead for like a minute and a half, waiting for the solder to turn liquid when they touch it to the wire away from the soldering iron. Just a dab of solder, heat it up, and then apply it. It goes so fast. And then you clean it by wiping it on a copper sponge, copper wool pad. All right, here's one. Oh boy, I think the stream's gonna go kind of late. The other project that I was going to work on. So there are several little tiny grade crossings, road crossings on the mainline track, and they have little, signals. Like one of them actually has like the little, bars that swing down, like when cars are not supposed to cross because there's a train coming. We have those on one of the grade crossings, little tiny ones, and they're cute and they're cool and they kind of work. And there's a couple other crossings that just have flashing lights, but the manager gave me a kit for an older style. They do raise and lower as the train approaches. Yeah, they are automated. When there is an ammeter connected to that section of track, so that when there is any current being drawn by a train going across those rails, it knows that there is a train there, and it will send a signal for the gates to lower. And there's a bunch of those. There's only one that has the gates that lower, but there's a few that have flashing lights, older style ones. There is another older style of grade crossing signal called a wigwag signal, which has like a thing hanging from above that will swing side to side with a red light on it. And I was given a kit for one of those. Like, hey, if you want to work on this and assemble it and put it over on this grade crossing to replace the simple flashing lights, that would be pretty cool. So I was thinking I might do that tonight after I'm done working on this thing, but no, God, there's no way it's going to take me so long to finish this. Also, I know why that LED was burned out. Because the manager fucking tests the LEDs with 3 volts and no resistor, which is overdriving them. Like, he has, to see if the LEDs are working, he has a battery holder with 2 AAAs in it and uses that to drive them directly with no resistor. And that's a terrible idea. And that is why one of those LEDs burned out. But I can't scold a man twice my age, so I can politely let him know what went wrong and make suggestions. And he does seem to appreciate my input a great deal. Like, after I built the Helpful Harry alarm system, like, between that to show overvolting, yeah, it does. Oh, man. So, oh my God, that power supply that I was just using can put out a maximum of 6 amps on the 5-volt line. 6 amps is a lot of amps for an LED. And I was working on a project where it did have a resistor and it was working fine. It was an infrared LED, an infrared emitter. And I bumped it with the side of my hand. It was just on a solderless breadboard. I bumped it and caused the resistor to be shorted out so that the LED was directed connectly across a 5-volt, 6-amp power supply. And my first indication that something had gone wrong was, what is that hissing noise? And then I looked over, and the infrared LED, which is not supposed to put out any visible light, was glowing red. And before I could reach over and shut off the power supply, it blew up, quite literally. The semiconductor die basically boiled and caused the epoxy carrier to rupture, and the front end of that LED shot off like a fucking pellet gun with a loud bang. And I still have both the front, I found the front half of it, like the dome half, like a year later, but I still have the back half of that exploded LED. It still has the anvil in it exposed, and it's just empty. There's nothing in there, and I stuck that in my bulletin board as a reminder. This is what happens if you overvolt an LED to an extreme degree. So don't do that. Anyway, yeah. That was fun. But yeah, so I built Helpful Harry to solve a problem with the club where people were arguing about the behavior of some club members not remembering to close the exit turnouts after they have gone through, leading to the trains behind them to go down the wrong track. And I was proactive and didn't really ask permission, and I just said, I'm just going to do this. I'm going to build this. I'm going to install it. If you don't like it, if we try it and you don't like it, then we can take it back out. It's not invasive in any way. But no, everyone freaking loves that, and everyone was really impressed with my electronic skills. So because of that, and because of my willingness to crawl under the layout and work on it, which nobody else wants to do except for the layout manager, who is an embattled old man who's been doing it by himself for years, he's really excited to have me there helping, working on the layout, And it was he was, last night trying to get this signal to work, and I came and diagnosed the problem where he'd been working on it for 4 days. Like, God, I can't get this to work. What? I don't understand the problem here, and I figured it out. He has such a high opinion of me now, to gloat a little bit, that I can just ask him for things for the club. Like, I sent him a 3-paragraph email saying, hey, I need these little half-inch eyelets to hang up the wiring so it's not all drooping down where I get my head caught in it. I can put that up with, and I do have proper Velcro, like server rack cable ties, reusable cable ties. But I sent him a 3-paragraph email explaining why I needed these eyelets, and he sent me a 1-word reply. Done. And they were here in 2 days. So that made me happy. All right. Let me do a count to make sure that I have done this correctly. Okay, 2 green, 2 brown, 2 black, and 2 red. And now they're tinned at both ends, so the manager doesn't have to tin them himself and do a horrible fucking job at it. I don't want to rag it on him because it's not really his fault, because it's like I said, he does it correct according to the textbook way that people have been teaching since the 60s. And it's just, a terrible way to do it, but that is how people learn to do it, and they just kind of get the idea, well, soldering fucking sucks, and that's how it is, and you just gotta, and like, no. It doesn't suck, and it doesn't take forever if you know a technique that, isn't that garbage. Okay. It's 1. But yeah, I'm really happy that he is as supportive. I know he's really happy to have my help and support there working on the layout. So I'm really happy that he is as supportive of when I suggest things. He will get me the parts to do them on club budget. Like, one of the things is there are a million Euro style screw terminal blocks to connect wiring together under the layout. And that old building gets really hot and really cold, and thermal expansion and contraction is bad for those kind of terminal blocks, and they loosen over time. So I was like, hey, one of the things we can do is replace a lot of those. Yes, both, because of both of those things. I suggested, hey, let's, these, I get it. This was what was standard when this club was built, but they have better stuff now. I showed him modern lever lock terminal blocks, which are spring loaded. They don't come loose from thermal expansion and contraction. And he was like, oh yeah, that's cool. So I talked him into buying like a box of 60 of them and to try them out. They're kind of expensive. But yeah, he bought 1 box of them of a bunch of different styles and like splitters and stuff. And I've been installing those in the club whenever I see a screw terminal block that is just fucking horrible and needs to be fixed up and replaced. And he thought that was really cool and was supportive of me about it, and that makes me really happy. All right, we are 3 down. As technically we are yeah, he's a really cool guy in general. I like him a lot. That is not true of everyone at that club. Everyone, so like Okay, we are 12 down, 4 to go for tinning ends. Um, so the first time that because like one of my choir friends, one of the people in my choir section when I first moved to this town, um, and I didn't know anyone here, and I was kind of lonely, and it's like, I haven't made any friends yet. It's my first quarter at this university, and we were talking in choir, and he was like, "Oh yeah, I'm in a model train club," and I was like, "You have my undivided attention. That sounds interesting." So he invited me to an open house, and I went down and checked it out, and I don't really know what I was expecting, but it is so much cooler than I thought it would be. Or like, I don't know how cool I thought it would be or uncool. It's like, yeah, it's a nerdy old people hobby, but it's neat. I think it's neat. But like, I didn't expect this club to be, something that was so cool that, oh, I want to get involved in that. But like, the layout is HO scale, and it's 680 feet of track, and I don't know what that is in real units, but it's um 11 and a quarter scale miles, which is a long fucking track. It is a pretty big layout. It looks really cool, and after seeing underneath it, like running the trains was fun. Like the manager loaned me a train my first day there, and I ran that, and that was neat. But then it's like, yeah, I'm interested in the layout. I want to work on the layout. Um, but of course, as my girlfriend Looney says, uh, the 264 meters. Um, the Looney has said, Lunetta has said that model trains are the most well-known hobby that nobody actually does because it's mostly old dudes who were, alive when trains were a fucking relevant form of transportation in the United States. So they are excited anytime anyone under the age of 50 shows an interest in model trains. But it's a bunch of old white guys, which I expect to be relatively conservative. Uh, you know, not nice to jump to conclusions about people, but like demographically speaking. And so we got out of there, and I said afterwards, after being there for like 3 hours chasing a train around the layout, I said, "Yeah, that's really cool." As my choir friend and I were leaving, I was like, "Yeah, that's really cool, but I kind of want to get involved, but I'm a little bit worried about being a transgender person, going to that fucking place full of old white guys." And he was like, "Oh no, they're actually all really cool. They're all chill about that. None of them are like super conservative." And he was correct. There are a couple who make me slightly uncomfortable, but I've kind of asserted my dominance in that space. Like, I'm gonna fucking be here, so tough luck. Um, and but there's like two or three of them maybe. They don't interact with me that much. Everyone else is really cool, and they're all really happy to have me there, especially now that I'm working on the layout. So, also it was really funny because I was working under there, and it's like I'm working on stuff that is over my head. Uh, and all of the tinning is done. It is time to put wires together. Um, I'm working over top of my head, and so it's like, I've been on HRT for well over a decade now. I am an old Tran, but let's see, I should actually use the other end of this one. Um, complexity wise, oh, physically over my head, stuff on the bottom, the underside of the layout table. Um, I've not run into anything that was electrically over my head yet. But yeah, working working over my head, I was like, oh, well, the HRT has certainly worked because I dropped something and caught it with my chest. Hi! Welcome, welcome. Thank you for joining in. Always a pleasure to see you here. I'm just fucking doing wire soldering on repairing a signal system for the model train club. Rewiring all of the LEDs because the beginning of the stream was a 40-minute rant about how old people don't know how to solder well. Because 3 generations of Americans all learned the worst fucking way to solder and take it as gospel. So I'm redoing the wiring that the layout manager did in order to fix problems. So right now I am preparing the wiring that will go onto the LEDs, which have been salvaged from the old wiring, one of which was burned out and had to be replaced. Okay. Yeah. What's the focus on this? I haven't even bothered paying attention to the camera focus, but what's this end? This is going to be, since I'm already putting the long underside pigtails, routing it through the structure is going to be more interesting than it was last time, but it saves me headaches in other ways, so we're just doing it. All right, 3. Excuse me. Also, the third hand, these fucking alligator clip things, are the most frustrating tool that I have to use on a regular basis. They are truly a pain in the ass. Okay. Good enough. Yeah, it's good enough. Yep. Very definitely. Like, one of these is slightly better quality than the other one, but they're both just kind of janky, because you can kind of see where on this one the alligator clips are just pushed onto pegs, and on this one they're like clamped into sockets, which is a little bit better, but okay. That's 5 down 8, or 5 down 3 to go. There we go. All right, that's 6 down. Hey, end of music. How does my audio sound to you in terms of quality of how my speech is coming through and relative volume of my voice and the fume extractor fan, which is running in the back, and the music that I have running in the background? The music is in the background virtually. The fume extractor is in the background, literally, physically. It's like if I turn up the noise suppression good enough for the fan to be completely inaudible, then my voice comes through all garbled. Oh, okay, cool. I can turn up the music. Actually, I want the music a little bit louder for my own purposes too, so that I don't have to fucking listen to the fan being quite so loud relative to everything else in my monitor headset. But thank you. Oh, that's a long one. I forgot to move the black thing in here so that you can actually see what the fuck I'm doing. Last one. Okay. I'm now done soldering for the moment. It'll be a relatively brief moment. However, I need to heat shrink these. Wow, that one kind of looks like ass, but it's a solid connection. I'll go with it. This one have them. No, it doesn't. I need the other box. Also, the sun is going down. I should probably turn on my light in here so I can see what I'm doing away from the workbench. Oh, my neck is starting to hurt too. There it is. Itty bitty. Heat shrink tubing. So, each of those will cover, I'll call that 2. So I'll grab 4 of these for the moment. Cut them all in half. And for each wire, we get the heat gun, which I'm going to not do on camera because I don't want the heat gun that close to the desk. But heat shrink. Oops, again. Heat gun. turn the heat down on it slightly because the other day I was using it to melt the ends of some nylon webbing, which takes a bit more heat. Okay. That is one down. There. Oh. Oh. That size of heat shrink doesn't quite like the silicone insulated wire. No, I think I got it in there. Okay. That barely fit though. Yep, that's enough. Yep. So I'll do one on stream. There we go. That wasn't in focus, but I don't care at the moment. Right now I'm kind of in just want to get this done mode. Oops. I've been falling everywhere. Stay up there. Whoops. I accidentally put it on high for a second. Don't want to do that. Yeah, getting the I'm kind of a little bit going above and beyond with this, but hey, the manager already soldered on the pigtails once, and I don't want to cut them off, give it to him, and have him have to do it again. But also, doing it myself means his mediocre soldering is no longer a factor in how well this will or won't work. Get that there. Last one. Oh, that's the silicone again. There we go. That's good enough. All right. That is that's the end of that. Now, I need more heat shrink. Whoops. But for this, I need to cut it into thirds, quarters. Want a little bit of overlap there. Quarters is probably fine. Let's see, how many do I need? 2 if I'm doing quarters. Kind of want to do thirds just to be safe. So I'll grab 3. These down out there. And about there. All right. Now it is finally time. Time is finally upon us to once again solder directly to the LEDs. So, anvil is... I want the anvil away from me. And we're going to start with green is positive, red is positive. I'm going to put those back up here because I'm only going to do negative first. I'll grab one of the brown ones. I will slide a piece of heat shrink on there so that I don't have to fit it over the previous heat shrink. Get that lined up. Good enough, I think. Give it a second to cool. And yeah, we're good. That is on the anvil side. Good. I'll grab the other brown one. Put that on a red LED so I can put the brown ones both on the same side so we know which side is which. Red. Anvil goes. Oh, for me? Yep. Ah. I don't like all of that paint that's there. I don't know what high temperatures do to acrylic paint, but I don't want to find out either. Good enough. Although the fume extractor is helping somewhat. Although, counterpoint, I want to move the fume extractor closer. See how much that affects the noise. There we go. On the inside of the LED lead, I actually want the wire to be a little bit shorter. Come on. All right, there we go. Finally. All right, that is both of the brown ones done. Where did I set the other one? That's black, that's black. Oh, there it is. There. Black wire. Heat shrink is on it. Red LED. Anvil facing away from me. And one more black wire. Heat shrink. And last LED. Anvil facing away from me. Yeah. That one still kind of has a blob of sun. There we go. And I want to shorten that wire. That. Come on. There we go. I think. There we go. Okay. Black wires are on all of the LEDs. So now I gotta do the positive side. That way. And that is a green LED, so I want a green wire. Oh, come on. Heat shrink tubing. Looks good. All right, one LED is done. Fantabulous. Another LED. This one is red. Red wire. That wire is too long. Go. Come on. Good enough. So anyway, how is everyone else feeling? For the 2 or possibly 3 people who are watching. Did I forget to? Yeah, I did. I'm schmott. I knew I would do that eventually. I forgot to put heat shrink tubing on this one. Come on, there we go. Ooh. Yeah, I hear that. Ah! How did I lose my whole damn solder spool? You can kind of tell that my energy level is winding down, so it's a good thing that I am almost done. Okay. LED number 2. Wiring finished. LED number 3 is also red. Come on. I had to cut the end off that wire. Go. Three LEDs finished. Did I forget to fucking put... Yeah, I did. God, I'm incredible. Redoing that again. Heat shrink tubing. Brilliant. Okay. There. 3 LEDs done. One more wire to solder. Here we go. Okay, and this time I'll remember the damn heat shrink. With that should be fine. Trim that wire a little bit. Yeah, that turned out. Excellent. Okay. Now, the electrical soldering is done. What is not done is the structural soldering. Because some of these wire tie downs, one of them just outright broke off. And I need to put a new one on. I almost just bit the camera on accident. Yep, I need to put a new one on right there. Oh, how am I going to do that? Start by retinning that spot. Go. Good enough. Now. Oh, where did I put the box of hook-up wire? There it is. Go ahead and, whoops, cut off like really long chunk of insulation. Not about that long of a piece. No, that's actually too long. That's okay. Whoops. All right. Holding this in place is going to be an interesting challenge. I think the last time I did this, I just used the third hand, but it's really awkward. This way. Come on. There is a little bit of hysteresis in the movement of this arm, which is really frustrating. That makes it so much more difficult to get it placed just right. Okay. Now I have to fit the damn soldering tip in there. As I proceed to get a bunch of it on the fucking alligator clip. Yeah, that's not working. You know what we're actually gonna do? That I would have done to begin with if I was smart. We're gonna use a way longer piece of wire. And then just trim it to length after. There we go. I don't know how well anyone can see that, but I'm assuming the answer is barely at all. But, oh well, that's okay. Whoops. Okay. Think that did the trick. That did the trick. Cool. That one is replaced. I will trim it later. That's fine, that's fine, that's fine. That one looks like the manager redid it, not me. So does that one, kind of. Or it came that way from the factory. That's fine, that's fine. And those two are fine. I replaced this one last time I worked on it, and that one was really hard to get to. That little bitch right there. That was frustrating. But okay. So that's on there, and I will trim it to length later when I am ready to. Which means I'm done with the soldering iron. Out of the way, move that out of the way. Make sure that the tip is clean. And it is. And now, heat gun. I'm also going to test illuminate these before I put them in the thing. Helps to plug in the heat gun. The very last thing that I will do is repaint the backs of the LEDs. I will do that to let it dry overnight. All right. Okay, that's 2. Come on. According to the VU meter on OBS, you guys cannot hear the heat gun at all. It's 3. I think the next time I do this, I'm going to wear my earbuds instead of my monitor headset, just because it's kind of heavy and my neck's kind of starting to hurt. Okay. Those are now all heat shrink. Now the next thing that I need to do, it's a little bit tedious, is to twist them, for which I will use the flat vise. The LED in there, clamp it. And I need this to be a twisted pair. It doesn't need to be for noise reasons, but it does need to be for neatness inside the model reasons. Come on. And then I will heat shrink at the very bottom after this twisting is finished. It's a little bit loose up there. I don't like that. Yeah, it's better, I guess. Now let's heat shrink the large wire back here. Yeah, I gotta take my headset off. It's driving me crazy. That's okay. It doesn't really make a difference. Okay. I think I will use the blue heat shrink. Just because it's the correct size. At least I think it is. You know what? That's a little bit undersized, actually. So, how does the clear heat look with it? I think it's a little bit too big. I'm gonna look in the other box. Because there is another box. Ah. I'm almost out of the green, but that does look like a good size for this. I could probably use the blue for the others with the... Let me try the blue that's in this box. No, this looks like it's the same size. Yeah, it's too tight with the green silicone insulation, but it should be fine for the other ones. So, cut that. Get rid of this piece of solder that was stuck to the table. Cut this into quarters. Bang the heat gun really hard against the camera, so that kind of messed things up. Cut this into quarters. Put one on here. Actually, you know, I'm going to put those on after I have fed the wire through. Okay. Well, there's one. Done. Ready to go in the thing. I'll go ahead and test it. Green goes in the top hole. I used way too long of a piece of heat shrink on one of those, but that's sort of okay and doesn't matter in this application. I forgot that I was going to test illuminate these before installing them, but you know what? I'm sure it's fine, and I won't regret saying that that's fine. Get just the right amount of through protrusion. That's about good. Okay. Green light is in. And let's see, that is green and brown. I need red and brown. Which is, this is a mess. There it is. Okay, that's red and brown. So we'll once again go through here. And, want under or over that bar? I think I want it over the bar. Silicone does not like sliding over that stainless steel. All right. Almost there. And that doesn't want to go. There we go. About the right amount of protrusion. I forgot to twist it. Once again, I am schmott. I will go ahead and twist it now. Looking okay up there. Yeah, I think it is. Good enough. No one is going to look that close. Twisting wire like this is slightly more of an art than it looks like at first glance. You need to twist them around each other without twisting them around themselves. Which is a statement that definitely makes sense without needing a visual aid. Don't worry about it. Okay, there we go. All right, both wires are twisted. Now, both of them have to go down through here. Nope, wrong. There we go. Wrong hole. And the other one. There we go. Right? Now we need to get them through that little hole in the bottom. So this is going to be easiest if I feed it one wire at a time, because that hole is very small. Might in fact need to be enlarged even for just the small gauge silicone wire to all fit through it. In fact, I'm going to call it now and say that that hole is definitely going to need to be enlarged. I'm also going to have to untwist this a little bit to have enough wire for that to be a thing I can do. Okay, that one is through. Come on. There we go. Yeah, this is a mite frustrating. Okay, I'm definitely going to have to enlarge that hole. No chance in hell. That out. This out. How large can I go with it? Not very much. Actually, can I bend that away? I think I can bend that away and then bend it back, and that will. Well, maybe not. That looks like it is soldered. Yeah, I'm not going to mess with that. Just going to enlarge it just a little bit. I'm going to try to do by hand. But I don't know, maybe I won't be able to get enough of a grip on the bit. I can find an appropriate sized bit. Pretty sure this one is too small. Oh, no, that is larger than the hole in the stainless. Okay. There we go. It's a little bit larger. Not by very much. Want to go larger still. Too big. Very definitely. This is almost certainly too large. Yeah, because the problem is it's going to catch on the like stainless L bracket right there is so close to the edge of the hole. I can only go very, very, very slightly larger. Oh, this might be okay. I think this will be okay. Not really supposed to use drill bits like this, but I frequently do anyway. You know, actually, let me see if this will fit in the pin vise. Shockingly, a pin vise is not a thing that I actually owned, but the club manager, the layout manager, loaned me one. Nope, that collet is too small. That bit will not fit. Oh, am I going to do this with power tools? I guess I'm doing this with power tools. I don't really want to. No, I'm not doing this with power tools. It's so close that I will definitely damage something if I try that. And I don't want to do that. I had a smaller reamer. Actually, you know what? The point on my 1/2-inch hand reamer might actually work for this. I will try it. If I can figure out where the reamers are. Where is that box? There it is. We will check and see if that. No, I want the 1/2-inch. Don't think that one will do it, but it might. This is the new 1/2-inch reamer. I think this one will do it. I don't think I've used this one yet. Where is the handle for it? There it is. I need to have these handles permanently installed, but I don't have a fucking arbor press to do that myself right now. Come on. Is that cutting? Yeah, it is. So close. Come on. There we go. Yeah, now that is working. I could also use the round needle file to like move the center of the hole over. But go a little bit bigger. There we go. Now, hopefully, I'll actually try the green one first because that one has the largest and therefore most frustrating insulation. untwist this just a little bit. And this wire through that hole. Get it lined up. There we go. All right, now run the brown wire, ground. And will heat shrink section get past? Yes, it will. All right. Fantastic. Let's go ahead and retwist that a little bit. All right, now the red side. Red wire in. Come on. 8 o'clock. I have been going for 3 hours. That is okay. Knock on wood, shouldn't be too much longer. Come on, pull it right through. There we go. Retwist that a little bit. Yay! All 4 holes went, or all 4 wires went through. Huzzah! Come on, match those up. Okay. Cool, 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 cool. Now, I need to seat the wiring underneath tabs to lock it in place. Start with the red one. Okay, and then the green one. Yeah, this is the smallest gauge wiring I have, and it's still quite a lot larger than the wiring that was originally in it. But I think that's okay. Clamp that down. To lock that wiring in place. Awesome. First wire lock is in place. Now the next one, which is right in the very, very, very corner. You need to get the wiring over it and pull it relatively taut. There we go. Tight. The other one. There. It. Make sure both of these are pulled relatively tight and pressed. They're not really going to press down very well, but oh well. Come on. All right, fuck it, just go ahead and lock that one. Get it? I can't with that. Yeah, that one I put in myself when I was working on it last time, and I think I didn't quite make it long enough. But honestly, this looks just as good as when the manager redid my wiring, so it doesn't look worse than it was when it was handed back to me yesterday. So it's fine. Okay, lock that one. In there and lock that one. And the last one, which is the one that I just put on today and needs to be shortened. Shorten it to about there. And lock that one. All right, huzzah! That's one side in. Excellent. Okay, I will, let me go ahead and heat shrink these before I continue with the other side. Yay! I can use the blue on this. Where did I fucking put that? You don't want to use heat shrink only shrinks so far, and you don't want to use heat shrink that is way too big, but you also don't want to use heat shrink that is so tight, in my experience, that is such a snug fit before you shrink it, because if it doesn't have any room to contract, it won't actually work. So we're gonna go ahead and go with that. The blue will work for the thinner PVC insulation wire. Do one up near the junction. Other down kind of near the bottom. All right. Done, 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 done. Then on the green and brown side, I have to use the green heat shrink, slightly larger for the silicone insulation. I love silicone insulation wire. I will not buy PVC insulation wire anymore. Piece up near the top. The piece down near the bottom. Fantastic. All right. Those are on. That is one side of this thing. Done. Really happy with that. Still need to do the electrical tests, but thank you. Yeah, I'm happy with that. That out of the way. Okay. Next one. Put in the red. All right, I didn't twist these. Let me go ahead and twist both of these lines before I continue with that. It's easier to do when it's not in the thing yet. Clamp it there. All right. Twist it quite all the way. That one is ready. This one. I don't yank the wires off. Last one. Wow, that webcam gets kind of warm. Okay. Oops. Go ahead and feed this through. Back here. Tweezers. focus this more up here. Dang it. The wiring up there so it's not dragging all of this down. In, not that far, back a little bit. All that good. Okay, green one is in. And the red one in through the same way. And protrusions about there. And the red one's in. To feed all of this down through here. One. I just realized I didn't enlarge the hole yet. That's okay, I'll do that in a second. Oops. It got wrapped around there. There. And that one's through. Okay. Wiring is routed there. Now I need to enlarge the hole where it goes through down here. Oh, that went pretty easy. And then the reamer. Almost there. There we go. Okay. That is through. Hypothetically go bigger than that, but I'll leave it at that for now. About the same size as the other one. So now you get out of my way. Did I? Oh wow, that one came really untwisted. Shit. Okay. Green wire goes in first. Black. And then the other two. Come on. There we go. One more. There we go. Okay. All of the wiring is through. Now I have to secure it as before. So there are there's one hook. Do red first. And then green. And that does not want to stay down. Okay, this one's going to be kind of difficult. You get down there, you get down there. I'll hold that in place with the tweezers while I use a different tool to bend that in place. Got it. Okay, those wires are locked there. Now, next one. This is a pretty tight corner due to the direction that that bottom girder goes. Right, that one. Okay, come on. Try to get it kind of flat in here. Then lock it down. All right. Then behind this one. Let's get the focus good there. Bend that down. Under this one. Bend that down. Pull these taut through here. Come on. And bend that down. All right. Finish twisting and heat shrinking these. One first. Oh, my back is starting to hurt. Okay, blue heat shrink. Put one near the top. And one near the bottom. It's done. Now the last couple of wires, the last two pieces of heat shrink. Yeah, this isn't really going to be meaningfully visible. Apologies for that. Stop twisting, god damn it. I mean, I'm trying to make you twist, but in a different way than you're twisting. And it's pissing me off. Okay. Second to last piece of heat shrink. Last piece of heat shrink. Done! Other than testing and painting. Ta-da! We made it to, well, the last straightaway, if not quite the finish line. But there she is. We're about there, I guess. Yeah. Maybe I should touch up those faces on those signals. Nah, I'm gonna make that someone else's problem. I'll just paint the backs of the LEDs. But rid of that. Now, I need to test the thing. So, couple of things that I need to do here. One, use the meter to make sure that none of those are shorted to the frame. So we'll go ahead and put this, flip that to there. Cool. No short. 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 And no short. Okay. Cool. Our insulation is fine. Our hand railing is not. Bloody hell. That got all messed up. Oh well, it's gonna have to be good enough. Go to the meter. Now, yeah, I'll call that good enough lighting for this. Need, you can see the light coming from my office window through the lens. Anyway, power supply. 5 volts and a ground. Here's the resistor. If I take, let's see, we want to start with this side. The black side. Yeah, that's the brown side, it's the black side. Let me see. That's positive. Ooh, it doesn't like that. Okay. Quick change of plans. I need to use alligator clips for this because those tinned wires are too big to fit in the breadboard. Okay. Black side, green light. Green is positive, black is negative. Turn it on. No. Why not? Yeah, that is correct. Great. I'm not getting green. I am getting red. Red works fantastically. I'm not going to bother to paint it if I have to undo this shit to fix another broken LED. Is it an intermittent connection somewhere? Please make sure that those aren't going to short out. Could have been that LED was just marginal because one of them was a lot dimmer than the others. Could have been that it was already damaged and soldering it kind of pushed it over the edge. Could be a broken bond wire or something. Yeah, I'm not getting anything for an intermittent connection. So, all right. Well, one of them don't work. Hey, Crack, welcome back. Just in time for me to be frustrated. Brown side. Red. Works fantastically. And green does in fact work. So, yeah, if I check this, green one with the meter, not your fault. Oops. Do have continuity on that. I do not have continuity on that. Okay. Yep, that's a bad LED. Means I get to undo one side of this thing. That's not happening tonight, which means this thing is not getting reinstalled tomorrow. I can still at least chase down that cable and figure out why the cable isn't working tomorrow under the layout, but dang it. Yeah, I think one of the that dimmer of the two green LEDs was just on the verge of going, and now it is gone. So, oh well. That is the end of what I'm doing tonight. I'm done. Got a lot of work done. But yeah, I'm going to have one side of this thing partly back apart to replace one of the LEDs. So, I'm going to set that aside. Oh, shit. It's 8:45 p.m. here. So, where is the other thing that I was going to look at? I don't know. It's somewhere around here. That grade crossing signal. I'll look at it. Oh, there it is. Yeah, so this will be kind of the next kit, HO scale. See if you look at the, turn that light off. Get this focused real well. There's like, staple is in the way of the illustration. Yeah, so unlike the swing down gate style grade crossing to physically block cars from going, and unlike the one that just has two red flashing lights like here and here, this one has a little arm that hangs down with a single red light and it swings side to side when there is a train coming. And so this one is that there's a little string that goes out from under each one, controlled by a motor that goes underneath the layout. So that's going to be kind of a thing. The manager said, well, you don't have to do it. It's not a big deal, but if you're interested in doing it, and I'm like, you can't just put a kit in front of me and expect me to not do it. So it's going to happen. Even though, just between you and me, I think wigwag signals like that are kind of ugly, but it does add visual interest to the layout. So I get wanting to put that on there. So that will happen eventually. I'm not even going to bother opening the kit tonight because I'm tired, and I have been going for almost 4 hours on the stream. So, yeah. I'm tired. Everything is unplugged, everything is shut off, so cool. Wind up my solder spool and go wash my hands. Always wear safety glasses when working with stuff like this, and also always wash your hands after working with leaded solder. But the thing is, yeah, thanks for tuning in. As a as a hobbyist, leaded solder is way easier to work with than lead-free solder. Downside, it has lead in it. It's 60% tin, 40% lead, I'm pretty sure. And yeah, SN60PB40 is what that says on the left. With rosin core, pine rosin core. This is now illegal to use in mass production of electronic components in much of the world for environmental reasons, mostly because they don't want it ending up in landfills. Like lead in e-waste is a problem. For hobbyist stuff, it's fine and it's way easier to work with, and it's just don't like eat anything or touch your face after using it without washing your hands really well first. So that's all there is to that. Anyway, all right. Cool. I should actually leave the camera this way, since this way it actually looks like I'm facing the camera when I'm have my head turned and I'm looking at chat. Anyway, so yeah, the signal bridge will not be going in the club tomorrow because it has a dead LED that I need to fix. I will probably not make that the subject of a Workbench stream. I will probably just do that over the weekend on my own, off cam. Next Workbench stream sometime next week will almost certainly be me unpacking and working on the Wigwag signal kit, looking at that, figuring out how much of a pain in the butt it's going to be to install. Whoops. So that'll be the next Workbench stream, which will be sometime next week. I'm not sure when, but I also want to do more gaming. We got to get through Fallout 1. I've got to kill the master. We've got to defeat the most horrifying villain I've ever seen in any piece of media, in any fucking video game. You will understand when you see it. So maybe Monday, probably Tuesday. Actually gonna, you know what? I'm gonna aim for game stream on Monday. I will, let's see. I would say that I'll try to stream 5 days next week, just because that would be cool to do, because I finally am confident enough with like my kit and stuff to do that. But Thursday, me and a bunch of my friends are going out to see Furiosa in the theaters. So there will probably not be a stream on Thursday, but I might do gaming on Monday, Wednesday, and Workbench stream with the Wigwag kit on Tuesday, and then Friday will either be more Fallout or another Workbench. Not sure. So that's the plan. Right now, I'm gonna go rest. I'm gonna take an ibuprofen because my back and my neck hurt from doing this. And I will see you all later. Thanks for watching. Bye.